Recording.
Uh,
Um, all right, guys. Well, welcome back. We are back with the CCNA journey. We're going to do things a little bit different since it's been a while. We are at part three, implementing VLANs and STP, as you guys can see on the side right here. We're going to do the review questions of 8, 9, and 10. Okay, tonight we're going to do that. We're going to come back, and on Sunday we're going to go over chapter 10. Okay, I'm going to try to cover that in whole. If it goes beyond 30 minutes, then we'll go, of course we'll do what we did previously, but we're going to go back and cover chapter 10. Okay, because whenever we get to part 4 of this book, we're going to start the fun part. We're going to start IPv4 addressing. Okay, all right, so let's go ahead and start these review questions and we'll go there. So it looks like DeMarco's the only one here now, so it'll just be me and him, but it's all good. So we'll start with question one. Question one. Let me close it. All right. In a LAN, in a local area network, which of the following terms best equates to the term VLAN? Is it A, collision domain? Is it B, broadcast domain? Is it C, subnet? Is it D, a single switch? Or is it E, a trunk? And you're muted, by the way.
so I'm gonna go with you said in the land, which of the following terms best equates to the term VLAN? I'm gonna go with
Yes.
a broadcast. I'm gonna go with broadcast domain simply because when you create a VLAN,
Yeah.
um that VLAN well when you I'm just trying to figure out how to say it, but when you create a VLAN, you're using that broadcast domain
Mm.
to simply send a message out to every host that's within that VLAN.
Right. Right. So again, it's a virtual LAN, right? So this is creating a local area network via software, correct? Because
Yep.
out of the box, right? A switch, right? You can connect it to a network is just and of course it's in its default VLAN. It is a broadcast domain. So when
Yep.
you create a VLAN, you are creating a virtual broadcast domain via software. So great job. So that was big. Yeah, good stuff. We'll just got to clean up that breakdown, okay? Just and remember that for the exam, okay?
Okay.
All right. So let's look at number two. Number two, imagine a small lab network with one local area network switch, one LAN switch, with the ports configured to be in 3 different VLANs. How many IP subnets do you need for the host connected to the switch ports, assuming that all hosts and all VLANs want to use TCP/IP?
Hold on, let me read that again.
No problem.
Ima-
Take your time.
Imagine a small lab network with one LAN switch, with the ports configured to be in 3 different VLANs. How many IP subnets do you need for the host to connect to the switch ports, assuming all hosts and all VLANs wants to use TCP/IP? So you'll use three simply because you have 3 separate VLANs, and each VLANs need
Boom.
its own.
That's
It
it.
needs its
Boom.
own. Got it.
That's it. Boom. You have 3 VLANs. Okay. You're gonna need 3 subnets. That's it. Easy. Okay. All right. The
Got it.
VLAN, the VLANs cover layer 2, but you also need a layer 3 instance for them to communicate. Okay. Boom. You'll need 3 subnets. So great job. Okay. Let's look at question three. Question three. Switch one sends a frame to switch two using 802.1q trunking, right? We talked about that. Which of the answers describe how switch one changes or adds to the Ethernet frame before forwarding the frame to switch two? A, inserts a 4-byte header and does change the MAC addresses. Is it B, inserts a 4-byte header and does not change the MAC addresses? C, encapsulates the original frame behind an entirely new Ethernet header? Or D, none of the answers are correct?
So I'll go with B because the MAC address don't change.
Boom, boom. And what is the 4-byte header that they're adding? Tell me
So
that.
the 4 byte header is the, 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 the-
You can look
I
it up.
got it. I got
You
I
can look it
got it.
up. Okay.
All right, hold on. Let me see something. The 4 byte header is. Let me see something real quick. I just want to make sure I'm explaining it right. But the full so it say it's the header of I don't know why it's saying 6 byte, but
Think about it, right? Read the question and think about what you learned, right? 802.1q, right? We need to know if it's traversing to switch using 802.1q. What do we need to add, right? We need to add what VLAN it belongs to, right?
hmm
We need to add priority. We need to add a couple of those things. That's what you learned within the chapter, right? That's what's in that 4 byte header, okay?
right. So it's the priority, it's the VLAN extension,
Yep.
it's the it's the priority, the VLAN extension. Uh, is it the I want to say the port? No, it's not the port.
Uh-uh. You're right, and we'll come back to this. We'll come back to this. It's all good.
Okay,
But I want you to review what it
okay,
does. Okay. All right. So just look back into chapter 8 about that. All right.
all right.
Okay. All right. So let's look at 4. Question 4. You are told that switch 1 is configured with the switch port mode dynamic auto command on its fast Ethernet 0/5 interface, which is connected to switch 2. Which of the following settings on the switch port mode command on switch 2, this is the other switch, that would allow trunking to work? Choose 2 answers. Okay. Is it A, trunk? Is it B, dynamic auto? Is it C, dynamic desirable? Is it D, access? Or is it E, none of the answers are correct? Remember, you choose 2 answers. And the other side is dynamic auto. And you can look back in the chapter if you need to for a second to look up what that means.
I mean, I know it gotta be a trunk because you gotta configure a trunk port in order for it to traverse the
Okay,
traffic. Let me see, desirable auto. And I feel like I took a note. Let me see. I feel like I took notes
no
and
problem. Look in the
I
chapter.
know I took
Look,
notes in
there,
desirable auto.
there should be a table. Okay, there should be a table within the chapter that goes over this. Okay.
Okay, I see it. Desirable auto negotiates a message in response to negotiate. No, that's dynamic desirable. Desirable auto passively waits to. Okay, so that's the one that actually waits for the trunking to be negotiated, right?
Right. So that that
Uh,
that waits for the messages, right?
right,
So it's
right.
so it's so it's when we say wait, it's listening.
Yeah, it's listening. Yep.
Okay. Okay. All right. So with that being said, if it's listening, right, we need somebody to be the initiator. Okay.
Right.
So
So it can pick it up on the other end.
exactly.
So it'll
Okay.
be dynamic desirable.
Okay. And what else? Because you have to choose two. Dynamic
So I
desirable absolutely initiates, but what would also initiate it as well?
uh, trunk.
Okay, right? So that would do it because, of course, you're statically saying, hey, this is a trunk. So with it statically being a trunk, it's automatically going to send those messages via layer 2 to negotiate that. Okay.
Yeah.
Okay. All right. Just review that within the chapter. Okay.
All right.
All right. Question 5. A switch has just arrived from Cisco. The switch has never been configured with any VLANs, but VTP, VLAN trunking protocol, has been disabled. Okay. An engineer configures the VLAN 22 and name Hannah's VLAN commands, and then exits configuration modes. Which of the following are true? Choose 2 answers. Okay. And take your time to read this question again. Okay.
A switch has just arrived from Cisco. The switch has never been configured with any VLANs, but VTP has been disabled. An engineer configures VLAN 22 and names Hannah's VLAN command and then exit configuration mode. Which of the following are true? VLAN 22 is listed in the output of the show VLAN brief command. VLAN 22 is listed in the output of the show running config command. VLAN 22 is not created in the process. VLAN 22 does not exist in that switch until at least one VLAN 22. So I'm gonna go with, so it's two. So VLAN 22 is listed because he did create VLAN 22. He configured VLAN 22. So it would
Okay.
show it in the show VLAN brief command.
So you so
VLAN,
you so you're saying A is one of
yeah,
the right answers? Okay.
yeah. All right. VLAN 22 is listed in the output of the show running config. So if he saved the running config, yeah, it will be shown in the running config because it did say he left out of he exit configuration mode. But I mean, I
So
don't know
so
if he
so let
saved
so
it.
let me so let me ask you this. Do you have to save your configuration for it to be in running config?
Nah, you don't.
Okay.
You don't have to save it for it to be run in running config. But I
Okay.
know if you exit out that switch, then you could possibly lose your running config.
That's correct. That's correct. But I just want to make a point, right?
Got it.
Because you were what your statement, because you can confuse yourself whenever you're in the exam setting, right? Is that the running config is the changes that you make while it's running, right? You are absolutely correct. If you don't save it to the startup config, yes, you will lose your configuration, right? But you're stable, right? You're stable, non-volatile, right?
Uh
Memory, right? Where your config is saved, that's gonna save beyond a restart, right? Or a power down event. Okay.
okay.
Right.
Yeah,
So yes.
I had a lab. I forgot to say the lab, and I went back to go do it. Whole lab was gone.
Mhm.
All my
So good.
configuration was gone, but everything was
Yep.
still there.
Yep. Yep. Okay. Yep. So A and B is correct. Of course, let's look at C. C, of course, VLAN 22 is not created by this process. That is false. You guys learned in this chapter how to create VLANs. And of course, D, VLAN 22 does not exist in that switch until at least one interface is assigned to that VLAN. That is false. A VLAN can be created and exist without interfaces being assigned to it. Okay, let's move to question 6, right? So question 6, which of the following commands identify switch interfaces as being trunking interfaces, right? Interfaces that currently operate as VLAN trunks. Choose two answers. I'll let you read the question, and of course, you choose two answers.
Which of the following commands identify switch interfaces as being trunk interfaces? Interfaces that currently operates as VLAN trunks. Show interfaces switchboard, show interfaces trunk, show trunks. So the commands will be show interfaces switchboard and show interfaces trunk if you want to see the trunk
Good job.
switch.
Okay, good stuff. You are correct. Okay, let's move on. All right, question 7. In a switch that disables VTP, an engineer configures the commands VLAN 30 and shut down VLAN 30. Which answers should be true about this switch? Choose two answers.
Switch that disables VTP. The engineer configures the command VLAN 30 and shuts down VLAN 30. Which answer would be true about this switch? Show VLAN brief command, should list VLAN 30. Show run config command, should list VLAN 30. Switch ship forward frames that around access port VLAN 30. I know that's not right. Switch ship forward frames that around on the trunk port tag with VLAN 30. If he shut it down, then it's not going to wrap anyway. So show VLAN. So show VLAN brief command should list VLAN 30, and B show running config should list VLAN 30. Because if you shut
That
it down, it's not.
that is absolutely correct. Even though we use the shutdown command, it does not mean the VLAN doesn't exist. So great job. All right, last question for chapter 8. Okay. Um, the show interface gigabit 0/1 trunk command provides three lists of VLAN IDs. Which items would limit the VLANs that appear in the first of the three lists of VLANs? I'm gonna let you read the question and of course read the answers.
Okay. The show interfaces gigabit 1 trunk command provides 3 lists of VLAN IDs. Which items would limit the VLANs that appear in the first 3 lists of VLANs? A shutdown VLAN 30 global command, a switchboard trunk allow VLAN interface subcommand, a spanning tree choice block, a no VLAN 30 global command. So the last 3 lists of VLANs. Which item would limit the VLANs that appear in the first of the 3 lists? So I know it ain't D and C. A shutdown VLAN 30 go. So it didn't shut down though. So it's B, a switch port trunk allow VLAN interface sub command interface sub command. Yeah, I'm gonna go with B because I mean it's not shut. It ain't a no VLAN 30 or STP. And then when
Awesome
you're talking
job.
about STP.
Awesome job. Okay. All right. We'll take a breather and then we'll go ahead and we'll move to chapter 9. Great job. Great job
Thank
breaking
you,
it
man.
down as
Appreciate it.
well. So let's go ahead and let's move on. 1 second.
Okay.
And again, chapter 9 is this is talking about spanning tree protocol concepts. So we talked about a lot there. I know it's been a while, but we'll go ahead and go over it and then we'll
Yep.
see
It's
where
kind of
we're
breaking
at.
up. It's staticky.
Yeah. Give me 1 second. Okay. Let's go ahead and share my screen again.
Okay.
Let me know if you can see that.
Yeah, I can see it. It's kind of staticky. It sound like a robot a little bit.
Oh, with me talking?
Yeah.
Oh, shoot. Hold on. What about now?
Say something.
Testing 1 2 3. Testing one two
Yeah.
three.
Yeah. It still sound like that.
Okay, hold on. Let me restart my headphones. Testing 1 2. Testing 1 2.
Yeah, I can hear you, but it still sound like that. I can hear you though.
It's still staticky. Huh.
Yeah. Yep.
Okay. Wow. That's weird. Um, Jesus, hold on. What about now?
Yeah, it still sound like that. Let me make sure it's not my headphones.
Okay.
I'm gonna disconnect my headphones and reconnect them.
Okay.
Say something, Dave.
Testing 1 2 3. Testing 1 2 3.
Say something.
Testing 1 2 3. Testing
Yeah, it
one
don't
two three.
sound like that, so it might. Hold on, let me make sure it's not mine,
Okay.
but it could be. Uh, can you hear me?
Yeah, I got you.
Ah, yeah. So it probably was mine. I just disconnected and reconnected.
Okay. No problem. No problem. All right. All right. Let's go ahead and get going again. This is the last questions that we'll go over, and then
Okay.
10 we'll go ahead and start 10 on Sunday. Okay.
All right,
All right.
that's cool.
All right. Question 1. Which of the following port states are stable states used when spanning tree has completed convergence? Choose 2 answers. A, blocking. B, forwarding. C, listening. D, learning. Or E, discarding.
So I'm gonna go with when it go with conversion, it's gonna be blocking and forwarding. It's definitely gonna be blocking and forwarding because
Why?
it's gonna be because that's the three. So you got blocking, forwarding, you got root port, blocking port, forwarding. And I know all three. I know the root switch always forwards frames.
Hmm.
Um, the switch that don't win the conversion, it has the blocking port.
Hmm.
So you got your You got your root switch, your designated. So is root switch designated? Is root port designated port
Right.
forwarding and blocking?
Right.
So those are the four. So if it's not doing, if it's not forwarding, if it's not forwarding or being a designated port, then it's going to be either block. I mean, if it's not a designated port or root port, it's going to be blocking and forward.
Yeah. And so, and that's exactly right. Right. Because with listening, learning, and discarding, right? This is within the process of convergence.
Mm-hmm.
Blocking and forwarding is at the end of the process of convergence, right?
Mm-hmm.
So this is why they would be stable states, because it's either blocking or forwarding as far as the end result of convergence when the process is done. Make
Got
sense?
it. Yep.
Okay. All right. So let's look at two. Which of the following bridge IDs wins election has root, assuming that the switches with these bridge IDs are in the same network? I'll let you read and you choose an answer.
I ain't gonna lie. I'm gonna try this one to the best of my ability because I really got to go back and look at the MAC addresses and
Take your
how
time.
they are.
Just remember the lowest one wins.
Got it. Which of the following bridge IDs when an election as root wins election as root, assuming that the switch with the bridge ID are in the same network? It's kind of weird. I really got to go back and look at the MAC addresses again because just to see how it could.
Let's break this down. Let's break this down, right? We're talking about
Mm-hmm.
the lowest bridge ID. What is the bridge ID? The bridge ID is the priority and the system MAC address combined.
So, yep.
Okay, so we have 4097, right?
Oh,
Compared to this. So we can go ahead and just delete A and B out
right,
of the selections, right? We also can delete 4096-1. That's more than this. So we can
right,
delete that. So all that's left is C and D. So of course we go one by one, right? 4 is the same, 0 is the same, 9 is the same, 7 is the same, 0 is the same, right? And we keep going, right? We start at the left and we go to the right, right? And 2 is the same, 0 is the same, 0 is the same.
got it. All
Uh-oh,
right, now you brought it back to my attention. Now, all right, so
uh-oh.
it'll be C. All
There you go. There you go.
right, got it,
Okay.
got it. So, ah, yeah,
Uh,
yeah, got it.
all right,
I just had
cool.
to remember how it was formed. So now that you broke it down to me that way, now it come back to me that it's the bridge ID.
Okay.
Yeah,
All
got
good.
it.
All good. All good. Okay. All right. So let's do question three, right? Which of the following are transitionary port states used only during the process of spanning tree convergence? Choose two answers. Now, since we talked about stable states, right? Now we're talking about transitionary port states. You should know the answer to this one.
So transitionary. So forwarding will be a transitionary.
No, it would not. It is the stable, it is the end result of
Oh, got
convergence.
it, got it. So it's listening and learning because that's the
There we go.
yeah, yeah. So yeah, so
Yeah,
that's the thing of a switch. So it listen, it what is it? It learns, it forwards, and span the tree.
there you go. Good stuff.
Got it.
Okay. All right. So let's look at four. Four is kind of broken up. Sorry. Which of the following facts determines how often a non-root bridge or switch sends an STP hello BPD message? All right. And if you want me to go to the other answers, let me know. I'll let you read the question again.
Which of the which of the following facts determines how often a non-root bridge or switch sends a STP hello BPDU message? The hello timer is configured on that switch. The hello timer is configured on the root switch. You can go down to the next two.
Okay.
Every it's always every 2 seconds. Switch reactive BPU. So it's C. The switch sends a hello BPDU every 2 seconds. Hello? Can you hear me?
Yeah, no, no, I'm listening.
Yeah, I
So
said
so C, you said it sends every 2 seconds.
yeah. So
So,
BPDU is sent out every 2 seconds, right?
mhm.
Or did I read the question wrong?
Which of the following facts determines how often a non-root bridge or switch sends an STP BPDU message? Read the answers again.
Uh, okay. Which of the following facts determines how often a non okay, so we're not even talking about a root switch. A non-root bridge or switch sends a hello BPDU message. The hello timer as configured on that switch. The hello timer as configured on the root switch. 2 seconds. The switch reacts. Let me see. I can't. Let's say you gotta go back to the last question.
Got you.
The switch reacts to BPDUs received from the root switch by sending another BPDU 2 seconds after receiving the non-root BPDU. Hello, timer.
Think about it. Think about it. All right. We become the root switch, right?
Mm-hmm. Mm-hmm.
There's conditions that have to be met before we arrive at a spanning tree topology, right? When the
Uh-huh.
BPDs are sent, is hey, did we agree on the hellos? Did we agree on this? Did we agree on the timers? Right? Once we
Okay.
agree on the timers, right? Now everybody needs to work off based off the root switch, right?
Okay.
And so now everybody based is working based off the root switch, right?
So
Because those
so
timers have to agree. What is the cadence that the non-root bridge and the switch needs to operate has? The hello timer has to be configured similar to what's on the root switch, right?
yep. So it'll be beating. And when you speak of the timers, we speaking of the every 2 seconds. We speaking of the 15-second forwarding, right?
Yep.
And we speaking of the 20-second
The max
the,
age.
the max age. All right,
Yep.
got it.
Yep. Yep. So make sure you review that, okay?
Okay.
All right. So question 5. Which of the following RSTP port states have the same name and purpose as a port state in traditional spanning tree? Okay. A, blocking. B, forwarding. C, listening. D, learning. And E, discarding.
So it's going to be uh let me see.
You can look at your notes. It's fine. You can look at your notes.
Let me see. Uh, which of the following are transitory? No, which one is it? Which one is it? Number 5. Which of the
Number
following?
5. Yeah.
Okay, which of the following Robert Spanish tree ports have the same name and purpose as a port state in the traditional spanning tree? Blocking, discarding. No, that's not. That's not. Listening, forward, listening, learning. So would it be forwarding? Would it be forwarding and learning?
Mm-mm.
Let me see. So it gotta be. So if it's let me say blocking, discarding.
Look
I
at it.
I I know it's I know it changed the name. So it did change the name when in the new spanner tree topology. So
What changed the name?
so discarding is now being used now
Has blocking, right?
as blocking. Yeah. So yeah, that's what it is.
But it's was discarding was used in spanning tree, right?
Nah. So it was.
You sure?
You said discarding wasn't used in spanning tree and regular spanning tree.
I'm asking you.
in traditional spanning tree?
I'm asking you, was it?
Nah, it wasn't used. It
You
was
sure? You sure?
yeah, I'm sure
Okay.
it wasn't
Okay.
used.
Okay. So what's your final? So what's your final answer?
So I'm gonna go with discarding.
Mhm.
I'm gonna go with discarding blocking.
Nope.
Uh,
The answer is forwarding and learning.
I said that right.
Yeah, I know. I just wanted to fuck with your
Right,
head a little
but
bit.
all right.
So you have to be sure whenever you get to the
Yeah,
exam, whenever you're all taking the exam, because you are going to question yourself.
yeah.
Okay. All right.
Got it.
All right. Okay. All right. Let's look at number 6. RSTP adds features beyond spanning tree that enable ports to be used for a role if another port on the same switch fails. Which of the following statements correctly describe a port role that is waiting to take over for another port role? Choose two answers. And this is question 6. I'll let you read it.
All right. Rapid spanning tree adds features beyond spanning tree that enable ports to be used for a row if another port on the same switch fails. Which of the following statements correctly describe a port row that is waiting to take over for another port row? Choose two. All right, so let's see. Choose two. So that's what it was that confused me. It's that alternate port.
Mhm.
So that's something that's being used now.
Yeah,
Um, so alternate port waits to become a root port. Backup port waits to become a root port. Alternate port waits to become alternate port waits to become a designated port. A backup port waits to become a designated port. So it ain't no backup ports. It's alternate. So I'm gonna go with A and C because once that port fails, then that alternate port will pick it up, even if it's in a blocking state. It'll automatically pick it up, and the one that was in a blocking state would now become a designated port.
close. Close. I want you to read back the information. So the answer is actually A and D. Okay.
A
An
and
alt
D. Okay.
an alternate port waits to become a root port, and a backup port waits to
Ways to
become a
be.
designated port.
Okay. Got it.
Okay.
All right.
All right. So number 7, right? What STP or RSTP feature caused an interface to be placed in a forwarding state as soon as the interface is physically active?
Uh,
This should be easy for you.
what spanning tree slash rapid spanning tree feature causes the interface to be placed in a forwarding state as soon as the interface becomes physically active?
Meaning it's not going through the different states.
Um, so it's let me see.
It's not going through convergence.
Spanning tree, ether channel. That ain't what it is. Root guard. No, that's something that you. So it's port fast.
There we go. There we go. Port facet enables the switch as soon as layer one is available, it's immediately going to be in a forwarding state, right? Typically,
Yeah.
typically applied to ports that connect down to end users, right? That connect to host and what have you. Okay.
Yep.
All right. Question 8 and last question, right? Which optional STP feature reacts to a subset of incoming spanning tree BPDUs to disable the port, but also allows and processes some other spanning tree BPDUs?
Guard, PPDU guard, loop guard, port fast, loop guard. It won't be loop guard because it's not looping. It won't be BPDU guard because that means it will block all the BPDUs that come on that port.
Good.
Root
Okay.
port, guard, root guard, port fast. So it'll be root guard.
There we go. Good stuff. Good stuff. One thing I like that you did tonight, you did the process of elimination. but you also give an explanation about why you chose your answer. So you need to remember to do that for the exam. Okay.
Okay, got it.
Along with the process of elimination, you have to be able to tell yourself the explanation of why a certain technology is the way that it is. Okay.
Yeah, now you always drilled it to my head that you
Yeah.
got to know how it works.
Yep. Yep. For sure. All right. So we'll go ahead and end here. Great review, and we will do chapter 10 on Sunday. Okay.
All right, that's cool. I
All right,
appreciate it,
boss.
Jay.
No
All right,
problem. Bye.
all right.